Hi, this is Janossy. I'm going to step you through a couple of slides that illustrate what the goals are of the Contemporary Computing course. These are the 5 units of the course: how computers work, how they evolved, modern computing, contemporary computing, and capstone projects that let you demonstrate what you've learned. Then finally, reflective work at the end of the term. Each one of these units is intended to take about 2 or 3 weeks, and the work in the units can be overlapped since you set your own schedule. How computers work. We're going to take a look at the basics of information encoding. The idea is that you get to understand how computers store information and how computers are standardized to do that. Computer evolution takes a quick look at the history of computers all the way from their invention in the 1940s using electromechanical equipment right through to the present, where we have very powerful, very tiny computers even in our cell phones. Contemporary computing takes a look at sound recording and editing, pictures, that is digital picture editing, and video editing, and some of the science behind those things. Your capstone projects are an interesting variety of things that let you demonstrate what you've learned in a variety of different areas, including work on the web to create a professional portfolio for yourself that will definitely be useful for you as you move on out of college and into the workforce. And finally, the reflective work, as it's constituted for this course, is not an essay, but it's information you gather and you actually are supplying on a form. It begins with you doing an interactive exercise that will help you understand what your likes and preferences are and what types of career paths might fit best with your interests. How computers work. Let's take a quick look at these things because the goal of this course is to have you learn these things. How are information and instructions digitally coded, and what manipulates it? That's basically what we're talking about here. And how do we objectively compare different computers and component choices? That's where a little bit of the science comes in here. That factual comparison is something you're going to be using in the projects associated with each unit. Goal is for you to be able to accurately explain these things to a friend who knows less than you do. So these items, in all cases, we're looking for you to develop this knowledge and these skills identified on these slides. Computer evolution. Well, the progression actually means how computers grew up in their use from mainframes, mini computers, personal computers, and the other types of computers. These generations of computers kind of overlap in some instances, but they're each dedicated to different kinds of processing. The question is, who do these computers interact with? Does it run on its own, or do people and processes interact with it? What we're going to see is that mainframes, those big monster machines, were typically batch. They wanted to run on their own. They could be adapted to interactive use where people would communicate with them as they worked. Mini computers were always interactive, as are personal computers. What you're used to doing with a personal computer has the computer being your servant and listening for your commands. Supercomputers, however, as you'll learn, do very high-speed, high-volume processing of scientific problems, and people don't interact with them as they're doing that. You might think of the machine going off there and thinking pretty hard and long, and that's called batch operation. And finally, embedded computers, the Curiosity rover on Mars, put there in August of 2012, this is something that uses embedded computers a great deal. These are computers that control the process of the equipment. And we'll talk more about that later. What you're going to learn how to do in this unit, in addition to a little bit of history, is learn how to integrate images with text. Once again, the goal being to accurately explain these things and how to do them to a friend who knows less than you do. Contemporary computing. Digital, sound, we want to learn the science and the skills. The same with digital images, the same with digital video. What this really means when I say science and skills is the how and the how-to. The goal is going to be able for you to know the how and demonstrate the how-to. And the last 2 topics we'll talk about, game genres and evolution, and animation basics, all get into the idea of simulating reality, either for recreation purposes or for training purposes. Finally, your capstone projects. What you're going to be doing is building a menu-based website, a professional portfolio. You're going to learn something about the internet structure by tracing the route of information through it. You're going to learn how to create multimedia-enabled training materials, and we'll be taking a look at predicting some of the future IT developments and their impacts on your career. The goal here, show you can do it. That's what the Capstone projects are all about. And finally, the reflective work centers on what did you learn and how does it apply to your life and career. That's what the goal of this course is.